Hey everyone, Dr. Tom McNamara here again for our course in trigonometry. In this video we are going to discuss some more applications of the half-angle formula, and I guess it's really half-angle formulas because we have two of them. So let's briefly review what those actually are. We have one formula for cosine A over 2. We have a second formula for sine A over 2. The formulas both involve a square root. The formulas both involve a fraction with a 2 in the bottom. The formulas both involve cosine. This one has a plus, this one has a minus, okay? Those guys match, plus. Those guys are different, minus. That's just how I remember it. It's not anything mathematical there. Okay, so we have our two half-angle formulas. In the last video we discussed an example of finding the exact value for, I think it was sine of 15 degrees or something like that. Okay, well 15 degrees is half of 30, so we use cosine 30, a known value, to work this out. Alright, so let's do another example here. I'm just going to pull one right out of the book. So, example, if sine A equals negative 8 over 17 with A in between 180 and 270. A is between 180 degrees and 270 degrees. We want to find sine of A over 2. All right. You might be thinking, okay, easy enough. We need sine of A over 2. We'll use the half-angle formula for sine. Okay, great. The only thing is, they didn't tell us the cosine of A, they told us the sine of A. So that's the first thing we're going to have to figure out. We're going to have to figure out what the cosine of this angle A is. Second thing is we're going to have to decide, should this be a positive or should this be a negative? Okay, so let's do that first part right now. We're going to find cosine A. All right, well, A is between 180 and 270. So let me adjust that picture. That's going to put me in the third quadrant. Okay, my angle A is somewhere over here. Now they tell me the sine of angle A. So going back to the very first definition we had for the trig functions. Sine theta is y over r. So I got a point here with an x-coordinate and a y-coordinate. My y-coordinate is negative 8, and r is 17. That's the distance from the origin. I'm going to make myself a little triangle here, with that side being 8. Right? If my y-coordinate is minus 8, I must have gone down 8 units from the x-axis. So the question is, what is that x-coordinate? Well, we're going to use the Pythagorean Theorem. Okay? X squared plus 8 squared has got to be equal to 17. All right, now I know square of 8 is 64. Okay, now my question is, what's 17 squared? Okay, so let me see, 17 squared. So I'm going to do 100 plus 140 plus 49. Okay, 17 squared is 289. Okay, so x equals, so I do 289 minus 64. Oh, 225. Ha! X equals 15. It worked out to be a whole number. I wasn't expecting that. Okay, so that's my x-coordinate. In fact, I guess my x-coordinate is negative 15, right? Because this is 15 units, but it's to the left. Okay? So, all that tells me that cosine A is equal to negative 15 over 17. All right, now I can take that and plug it in right here in the half angle formula for sine. So sine A over 2 equals plus or minus square root 1 minus negative 15 over 17, whole thing over 2. All right, underneath this square root, I'm going to hit everything with a 17. Okay, hit this with a 17, the denominator cancels. Hit this with a 17, it becomes a 17. Hit this with a 17, it becomes a 34. All right, so square root of 39 over 34. I don't think that can be simplified. That's just going to have to stay as is. Now the question is, should I use the plus sign or should I use the minus sign? That's the reason they told us where A lives. A lives between 180 and 270. All right? So, when we're talking about A over 2, so my angle A being between 180 and 270, well, if I want to know bounds for A over 2, well, I just cut these in half. So if A is between 180 and 270, then A over 2 has to be between 90 and 135. And I got those numbers just by cutting these numbers in half. I cut the middle in half, I got to cut these in half. All right? Now, if my angle is between 90 and 135, that's putting me in the second quadrant. I'm over here, right, because that's 180, 90 right there. So I'm in the second quadrant where the sign is positive. So I should choose the plus. All right, so sine of A over 2 is right there. All right. Let's do another quick application of half angle formulas. Okay, how about this one here? Graph y equals 6 sine squared x over 2. All right, we've seen this a few times already in this course. We're going to apply the formulas that we know to simplify this expression. Right now, it's got a square. We've got a trig function squared. So the basics that we know about graphing, find the amplitude, find the period, find the vertical and horizontal shifts, those don't quite work because those apply to just straight trig functions. This is a trig function squared, so that's out the window. However, if we use the half angle formulas, then we can do some simplification. One minus cosine x over 2 squared. All right, what's going on here? Well, I know sine of x over 2. I know what that is. I can apply the half angle formula. This says sine squared. So I'm going to apply the half angle formula to sine of x over 2, getting this. 1 minus cosine x over 2, whole thing square root. And I'm going to square that. Okay, in other words, I'm replacing sine of x over 2 with this. Now you might say, well, you just made it more complicated. It didn't have a square root before, now it has a square root. But notice it's squared. The whole thing is squared. So those two operations undo each other. Okay. Now you might be saying, all right, where's this 3 coming from? Well, When you do this operation of squaring, it gets rid of the square root. We have 1 minus cosine x over 2. There's a 6 over here. The 6 will cancel with the 2, leaving us with that factor of 3. If I distribute the 3, I've got this. So this expression right here is equal to this one, and we can graph this one using our basic principles. All right, so I'm looking at this. Amplitude 3. Remember, amplitude can never be negative. I know there's a minus right there, but the amplitude is 3. Period, well, there's no multiplier out here, so the period is 2 pi. My vertical shift, up 3 units. Okay, so this is my midline right here. The line y equals 3. This function is going to oscillate about the line y equals 3. I take my period of 2 pi and I break it up into 4 equal pieces. Okay, so those are kind of my tick marks there. Alright, now what am I doing here? Well, I'm putting in my anchor points. I'm dealing with the cosine function. Oh, wait a minute, hold on, messed that up. I start down here, actually. Okay, I wanted to start up at the top because it's the cosine function, and then I looked at this. I saw that's negative. Remember what that does? It does a vertical reflection. Okay, so the graph will be upside down. So I'm actually going to start at the bottom, go to the midline, go up top here, back to the midline, back down to the bottom, connect these all with a nice smooth curve. And we have got the graph of this expression using the basic principles for graphing trig functions. Okay? So another instance where we apply those formulas to take a complicated expression and trade it in for one that is easier to work with. Okay? So get familiar with those half-angle formulas that we discussed. Very easy to remember because they're almost identical. They both involve the square root. They both have a fraction. They both have cosine. The only difference is the half-angle formula for cosine has a plus. The half-angle formula for sine has that minus in the numerator of the fraction.